You know what I'm talking about?
I'm asking
All right, so homework question that you guys may have. All right, what happened? Number 4. Okay, let's see what's number 4.
Yeah, you might.
More was slant, right? More was slant.
All right, number 4. Number 4 is a little bit more difficult to find x-intercept, and I say it on the group chat because I thought it was factorable, but it wasn't factorable. So you can actually use quadratic formula to find it. But other than that, there's no horizontal asymptotes. Hopefully, you find out there's no horizontal asymptote because the top degree is larger by 1. If the bottom degree is larger, then it's y equal to 0. If the same degree is the same coefficients, if it's larger by 1 degree on the top, that's gonna be a slant asymptote. So this is the one case that you have to deal with slant asymptote. So let's just take care of this and just say, hey, let's worry about let's say copy and let's paste here. Okay, so how do I find everything? So let's just say, hey, is any holes? But it turns out the top is not factorable, right? So it's not factorable. There's no big deal. So we're just gonna do long division to find out what the slant asymptote is. But we know vertical asymptote is that x minus 2 equal to 0, x equal to 2. We know we have one asymptote already. We also should know where's y-intercept. Where's the y-intercept? Well, that means I plug in 0 for x. That's going to be negative 24 over negative 2. That's equal to 12. So that means 0, 12. That's going to be a y-intercept. Is any x-intercept? Well, x-intercept's probably kind of hard to find because you set the numerator. Because if numerator is equal to 0, then the whole thing is equal to 0, right? It doesn't matter bottom if a numerator on the top is equal to 0. So technically, you can find x-intercept if you have x squared minus 4x minus 24 equal to 0. It turns out it's not factorable, but it doesn't mean it's no hope. It's actually, you can use quadratic formula. So it'll be negative 4 plus minus 16 minus 4 times negative 24. That all over 2. So that's equal to 4 plus minus square root of 96. So this one is 96. So it's what? 112 maybe? Over 2? That's what you got? Okay. Okay, so then you can actually plug in the calculator. Says, hey, what is 4 plus square root 112 over 2? Can somebody work out for me? So you can get 2x-intercept from there if you really want to. Can somebody work out for me or type in the decimals for me very quickly? Shreya, what'd you say? No, tell me because you're pretty reliable.
Negative 3 point something and like 6. Wait. Yeah, like 7 or yeah.
Negative 3 point something? 3 point what?
It was like 3.2 or something. I don't really. I had it in like.
Can somebody work it out for me on decimals? Type in the decimals. Can somebody type in the decimal?
Hey, can you move the sound thing?
Sure. Did somebody work out for me or no? My battery is dead, so I cannot work it out. Caleb, do you?
I got negative 3.2915.
Okay, and then this one is negative maybe 6.
And then the other one is 7.29.
Okay, so let's just go like with that. So that we find out a lot of things about it because we find out x-intercept. Now x-intercept usually is factor. On the test, you should be able to factor and solve it. Not very rarely, I'm gonna ask you quadratic formula. So 7.39, so that's gonna be right here and then right here, and the y-intercept is gonna be 0, 12. So that is gonna be 5. This is 5, so 12 is like this. So those are 3 points I know for sure on the thing. We also know that x equal to 2 is an asymptote. Okay, but we know there's another asymptote. What's another asymptote? Take this. I'll use synthetic because I feel like it's easier. And now plug in 2. So that's 1, 2. That's negative 2. Negative 2 times 2 is negative 4. So it'll be negative 28. So it'll be x minus 2. So x minus 2 is going to be like this. And it's going to be like this. Is that okay?
So, Mr. Gator, why did we need to do the synthetic division?
To find a oblique asymptote.
Yeah, but where are we? Oh, if there's a 0, then.
That's the whole thing, right?
Asymptote is different than whole. Asymptote is called non-removable discontinuity to be specific. In this case, is vertical asymptote is not a hole. Hole is just a line that goes through a hole. It actually can touch it. Like I don't know. A hole you can actually the function can actually touch the hole, but asymptote is like something you cannot touch. It's unless it's horizontal. Yes.
The division equal to 0, does that mean that there's no slight asymptote?
Yes, that means no slant asymptote.
Will we be calculator on the top then?
On decimals, no, you're gonna have to grab from scratch.
Oh, I mean like calculate when it comes to like for the quadratic calculation.
No, I won't give you one that you really require quadratic form. I'm gonna give you one that is required no quadratic formula.
Okay.
Yes, Caleb.
Why do you ignore the remainder?
Remainder is not it is not anything with deal with asymptote, so I don't have to deal with that. I only see what it can be factored out, and or what it can be the long divide, and that's the only thing I care about. I don't need to care about remainder. Unless remainder is 0, then it's a different story.
Okay.
5x minus 2. Then that will be your line, which is at y-intercept at -2, and the slope is a 5 over 1. Okay. So with that being said, now you say, hey, let's plug in to figure out what happened next to asymptote. Remember we talked about what happened next to asymptote? Is you're going to plug in something that just say, what happened when limits as x approach to 2 from the left? So what do I plug in? I plug in what? 1.9, right? 1.9 minus 2 is what? Negative, right? So 1.9 squared minus 4 times 1.9 minus 24. What do you think it's going to be? Is negative on the top or positive on the top? I think it's definitely negative. So it'll be negative over negative. So it's positive. Well, look at the graph. It does look like go into positive. And this part is going to go toward the asymptote. Remember, this part is going to go toward asymptote. Now, what if you plug in, let's say, 2.1? Well, 2.1 minus 2 and 2.1 squared minus 4 times 2.1 minus 24. I think top's still going to be negative, bottom's going to be positive. So it's going to be negative infinity. So this part is going to go here, and it's going to go this. So this is the graph that will be a more difficult one. That with the slant asymptote.
Well, we don't need to know that for pre-calc.
Slant asymptote, yes, is part of pre-calc curriculum, yes.
No, but like the positive and the negative thing.
No, for my test, yes, but for because next year you're gonna have to do the same thing. Next question. Yes.
Necessary to do all, like plus and minus stuff, like
I think it's important for next year, and I will test them
Yeah.
because and it's really easy to plug in. Like a lot of time, people think it's really difficult to plug in. I think just matters just plug in a number, especially in factor form is even easier. So it's something probably I give you on a test gonna be in factor form, so you can just figure out what the sum of all the sign together,
So, like,
and that will be the end.
like you don't like need it in like
You know, AP exam they don't want to graph this far.
on your test you're gonna have to
Yeah, you have to create a limit statement. But on AP exam, they do gonna ask you what does graph look like when limit x approach from.
but like the limit statement, like what do you want to
So let me finish this part first. So give me a second. What AP exam is gonna word it is they're gonna give you a graph and they're gonna ask you says what happened limit x approach, and you're gonna look at the graph. 2 from the left is gonna go positive infinity, and you're gonna choose the answer with a positive infinity. Or limit x approaches 2 from the right, then it's gonna go to negative infinity according to the graph. So on AP exam, they're gonna give you a graph, and they will ask you what happened if you approach 2 from the right and 2 from the left. And you can tell if it's 2 from the right, then it's gonna go to negative infinity. If 2 from the left, it's gonna go positive infinity. So that way, they will ask you that way. They will ask you the graph, and they will say, "Hey, what do you think the end behavior is?" Did that answer your question? They won't ask you to draw it. I will ask you to draw it, but they won't ask you to draw it.
on your test like you want the limit statement to be like when x is greater than 2.
When lemon, I will tell you says, okay, when I will probably ask you this: limit x approach 1 negative, that's equal to whatever. So in this case, it's equal to positive infinity. You're gonna write down positive infinity.
One question.
Yeah.
You find the middle one and go through the y equal minus 2.
Y equal to -2, which, oh, this one is because the long division, it's a net division. If I take this divided by this part is x minus 2. That means you graph y equal to x minus 2 because -2 is a y-intercept where the slope is positive 1. Any questions?
No, I get it now.
You guys just have to try to graph it, and if you go in to graph those each things, you'll figure out on the test it becomes second nature. Now, if you graph without checking your answer on decimals, then yeah, you're gonna struggle a lot on the test because you have no decimals to check with. You had to believe in, whatever you do the first time is correct, which is that's very dangerous. So that's why I said check your answer on decimals. If you wanted to do well on a test, double check. My test question is usually pretty simple. Right now, there's a lot more people who getting A's than people who not doing well. People who not doing well, you just have to consistent on trying, putting effort in there, and just get there. Sometimes, yes, you're gonna struggle a little bit, but sometimes if you do things like you start doing things the right way, it becomes a habit. It's a power of habit. If you don't have the right habit, like if you're working out like me, I'll go to weight room for 1 day and I'll give up. I was like, oh, I suck at this. I'll never gonna be strong like Nicholas, or right, I'll never be buff like him. I was like, yeah, I'll forget it. And that's what this is what's going to be with you. You are never gonna have a chance to be like as strong as it. Now, if you just consistently work out, you see some scrawny kid. Nicholas probably know a few kid that used to be scrawny and now they are buff as hell.
Smart.
Well, yeah, but it's only if you want to work though. If you don't want to work, doesn't matter what kind of teacher I am. So only if you want to work from something to the other thing, so the next step. So a lot of time people don't believe in that, and I really believe in that because I really think about most of my students that pass AP exam. They come in as really bad at math, but they come out like they are really good at math. But because people believe in me. It's not because of anything else. And they believe in me and they try the things that I ask them to try. I can be a good coach, but you gotta be the good player for me to coach you. Okay, next question.
Like graphing them all on the same graph.
Why?
I don't know. I thought we could.
Okay, next question. Any other question you want me to go over? Yup. No, it's good. Okay. Yes.
How do we know it doesn't have
Doesn't have a hole. That's a good question. When you don't have anything have a cancel factor, so if you have cancel factor, they have to have a hole. If you doesn't have, no, actually, let me take it back. Not all the time. So I'm gonna give you a situation that you have a cancel factor, have you have no holes. So that is kind of weird. So let's just say if you have this. This one, even though you have cancel factor, so like for example, this one is gonna factor like this, so you can put on the notes. This is x minus 2 times x minus 2, right? Sorry, this is plus. Now, if this cancel out like this, you thought there was hole, but you're gonna say, hey, look, there was still a denominator. So x minus 2 equal to 0, x equal to 2. So you say hole is at 2, but there was also vertical asymptote. Now, vertical asymptote override the hole because the vertical asymptote is like biggest badass there. If I'm vertical asymptote, that's just I'm vertical asymptote. That's just nothing can touch me. Right? But the hole then is still maybe. Okay, so if you have a hole and the vertical asymptote existing at the same x value, vertical asymptote wins. They are the one that they have a biggest priority over other things because you cannot divide it by 0. Does that make sense? So it doesn't. So unless you have a cancel factor and that cancel factor is not the same as a vertical asymptote, therefore they usually have a hole. Now, if they have the same exact one, then guess what? You don't have a hole anymore. You have vertical asymptote because vertical asymptote take the priority over other one. Questions? Yes.
So you mean x plus 2 is the vertical asymptote?
In this case, x equal to 2 is the vertical asymptote, not a hole, because they both land on the same x value. Even though cancel factor, it seems like it's hole, but they land on the same value, vertical asymptote supersedes. So for example, let me show you the graph. That way you can see it. Now you thought there was a hole there, but it doesn't have a hole there. So let's just say x minus 2. Sorry, let me cross it out. I just say x minus 2 divided by x squared minus 4x plus 4. Do you see that there is no hole there because there is not even a value to reach there? Like usually a hole is the sum both sides can reach to a value. But in this case, they both go in opposite direction. It's not connected into a single line. So most of the time you have holes like this. That's a hole. But this time it's reached at a value that just vertical asymptote is going to float down or float up and doesn't have a chance to see. You don't even see the thing that meet. They have to meet each other to get a hole. But in this case, they don't have a chance. Those two lines never meet each other. Questions? No, yes, maybe. Okay, let's go through some more difficult one. Okay, so f of x equal to x over x squared minus 1. It's still a rational function. So can you tell me how many different asymptotes is here? Write it down. Don't shout it. Write down how many different asymptotes there are. That's a good start. Maybe there's more. Okay, write it down. Where do you think the asymptote is? So you should consider slant. You should consider horizontal. You should consider vertical. How many asymptotes they are? So can you tell me? Can you write down that where is the asymptote is, and are they vertical or are they slant?
About the school.
No, you can come in. I'll give you a test now, so you don't have to start too late.
You can take it in the back. There you go. You can take it next.
Okay, how many asymptotes did you find? If you did it right, you should get 3. Well, think about it. Horizontal, you compare the degrees, right? So which degree is larger? The bottom degree is larger, right? So therefore, y is equal to 0 is your horizontal asymptote. You okay? Is that okay? Then x equal to plus minus 1 is your vertical asymptote. Does that make sense? Because you can take a bottom equal to 0, x squared equal to 1, and square both sides, so it's going to be plus minus 1. Here's equal to plus minus 1. So now I have a lot of asymptote. I have the asymptote at 0. So there's an asymptote. Now, remember, horizontal you can cross. Not big deal. You can cross in the middle. Only happen later. It's not going to cross. And at here, we're going to say this is a -1. This is a positive 1. It's going to create a blue asymptote. This one is cannot touch. The red asymptote you can touch. Is that okay? The red asymptote can touch in the middle. Can you tell me, is there any x-intercept or y-intercept here? What happens if you plug in, let's say x-intercept? X-intercept is, let's say y-intercept first. Y-intercept usually pretty easy. So y-intercept is what? 0. So it's going to be 0, 0, right? So 0, 0, this point. Wait, it touched the horizontal asymptote, but it's okay. Horizontal is fine. Horizontal is not vertical. Okay. So in the middle region of the graph, they can touch the horizontal asymptote. Only happen to the end, they usually plateau into the asymptote, which is horizontal. So in the middle region, it's perfectly okay. So in this part, so the red one can pass, the blue one cannot pass through. Now we just have to study how they behave right next to the asymptote. Yes?
Did you make your graph like bigger?
I have a bigger scale that
You're
-1.
doing a bigger scale right now?
Yeah, because I want to show you that -1 and 1 has 2 asymptotes there.
So is there 4 per 1 then?
In this case, I did 4 per 1, but I can change the scale anytime I want.
I did 4 per 1 also.
Okay, so now we say, hey, can I factor this? Is equal to x times x plus 1, x minus 1, right? Now, what I'm going to do is, I'm going to write down, what happened when limit x approach to -1 from the left side. So which value I will plug in to here? -1 from the left side. Negative what?
1 point.
-1.1. Plug into this one, x over x plus 1 and x minus 1, right? If you plug in -1.1, that's the top, that's negative sign, right? What happened to the bottom? -1.1 plus 1 and -1.1 minus 1. So the top is going to give you a negative sign, the bottom is going to give you a negative sign, and this is going to give you a negative sign. Is that okay? So it's eventually it's equal to negative sign or positive sign? Negative. So we know there's two options. One's going this way, one's going this way. Which one did they go? It was two options. Here, which choice I should choose? Down, right? I should choose this one. So this is the graph I'm going to. Is that okay? Now, what happened limits as x approach -1 from the positive side? Which value do I plug in? Or plug in? 7? Not 0.9. What is it? Negative 0.9. So you are plugging negative 0.9 because it's a little bit on the right of -1. So it's kind of confusing. I can see why he says that, because he's thinking about positive 1, but it's -1. -1 from the right hand side is going to be negative 0.9. Yes.
How do we differentiate whether we're going?
You look at it in relationship of this line. So on the left side it's from here, on the right side it's from here.
So if we see like limit its x approach is -1, we just find it from both sides.
Yeah, you want to see how do they reach both sides. Next year we're going to talk about a lot of that, which is first section, which is limits. This year I want to give you a preview of that so you can say, well, that's going to be the class I'm going to take next year, or not going to be the class you're going to take next year. Even though I think most of you guys can handle it, except if you don't do work. Yes. Gia, do you have a question? Gianna? No? I thought you raised your hand. Somebody raised your hand on this side. Okay, so now I'm plugging negative 0.9 here. So it'd be negative 0.9 plus 1 and negative 0.9 minus 1. What sign am I going to get? Negative on the top, right? Positive on the bottom, negative. So what's the sign it's going to be? Positive, because two negative signs is going to be positive. Positive times positive, positive. So we have choice, going this way or this way. Which way to go? Up. Because it has to go through 0, 0. 0, 0 is x intercept. Okay, what happened if you want to go to this one? It's negative, it's positive 1 now, so it'll be limit x approach to 1 from the left side. So what number I plug in? Roger? What number do I plug in? 1 from the left side. That's okay. Josiah? Yeah. 0.9. So I'm gonna plug it because this is a 1, right? From the left side is 0.9. So it'll be 0.9 on the top, 0.9 plus 1, and 0.9 minus 1. So that's gonna be positive over positive times negative. So it's equal to negative. So this side is gonna go to, there's two choices, either go up or go down. So which side do they go? Go down. Okay, and then I am gonna plug in the last one. Limits as x approach 1 from the positive side. Which number should I plug in? 1.1, so it'll be 1.1 over 1.1 plus 1, and then 1.1 minus 1. So they're all positive, right? So it's going to go this way or go this way. It's actually going to go up.
Can you plug that into this?
Yeah, I'm going to show you on Decimal. So this is what the graph is going to look like. And you say, hey, how do I know the graph look like this? Well, we can plug in. So it'll be x over x squared minus 1. It looks like this, right? X equal to 1. And we know this is a dotted line. I can press a little bit longer. It would be dotted like this. And the x equal to -1. And I'll press longer, so it's going to be negative sign like this. And x equal to 0. And it's going to be dotted line like this. No, y equal to 0, sorry. Like this. So this is what a graph is disciplined to be. And then you see this graph in general. Now, some people says, why do I plug in this? See, look at this. Why do I plug in 0.1 away, right? Give me a second. Let me finish this part. Why do I plug in 0.1 away? Just think about it. If I plug in negative 1.1, see that negative 1.1 is going to give you this point. It's, you know, it's negative value because you're so close to asymptote. They either be positive value or negative value. So you know the trend is going toward negative. So that's why I use a 0.1 away. And it's really easy to plug in because you don't care about the value. You only care about what kind of sign result is going to be. The sign is negative, that means the value is going to go to negative infinity. Sign is positive, that's going to go positive infinity. We can try again at this, let's say negative 0.9. And you see that this sign is going to go positive. And the positive is, I don't care about the value. I don't care it's 4.79368. I know it's positive. But it's so close to asymptote that either this way or this way. But if you get a positive value, it's going to go up. If you get negative, it's going to go down. Elizabeth, yeah.
If there's a vertical asymptote, like 2, would we use like 2.1?
2.1 and 1.9. And you see what kind of sign does that generate.
Okay.
You don't have to be very precise on the value. You only see, okay, the sign is positive. We know general trends because we study the end behavior rather than actual value, because we have decimals to graph actual value. We just need to see what is that without decimal. Can we see what a graph look like? And that's the goal.
So we just choose an x value close to the asymptote.
0.1 away.
Yeah. Okay.
0.1 less or 0.1 more.
Yeah.
Yes, yo.
Is the number like x squared and a number after that? Is it not just going to be like?
Yeah, if I change it to x squared, you're gonna see this what happened, right? If I change it to square, guess what? It looks like this. But if you study, if you plug in those values, you're gonna find out they give you a general trend. But and that's the thing. But also x squared also give me another asymptote. If I have x squared over x squared minus 1, what's the other asymptote? No, there's one more asymptote. Is the horizontal asymptote is no longer at 0. It's at where? No, they have same degree. They have 1. You have y equal to 1 rather than 0, because remember, if it's a 0, this is not true, because this one is actually touching, but you want to add a 1. You want to get closer than that. See, this is very, very much closer. It's never crossed that line. And next year, we're going to study more detail about this. This time, you can actually generalize the graph. What would a graph look like? Rather than, hey, it's something you don't know. But now you're going to try on decimal, see, hey, what do they graph look like? Does that make sense? Yes or no? Okay, let's try one.
No. He was running about this.
You can factor the bottom, yes. I think you can factor that now, right, Arthur? It's the only thing on DBA you pass.
Oh, good job.
Happen tomorrow.
What do you have tomorrow?
My DBA
For what?
for algebra 2.
Yes. That's all done.
I don't know whether I should take this class without like
I don't know.
algebra 2.
I think it's because I have such pride. Trust, man, trust.
Wait, did you take so I had Miss Davies at the beginning of the year. So I walked into Mr. Pearl's class and I said, "Can I have a 3x7 period?" And he said, "Are you serious?"
Everybody trying to switch out of my class, and you are trying to switch in.
Yeah, I switched. I specifically emailed him like, "Hey, can I have PA and Miss Clancy?" He emailed me back and goes, "Why?" And I went, "What?"
Why?
And he goes,
Do you
"Okay."
have Ivy? Oh,
I switched out of planner. He's pregnant. Gave birth. Easy A.
you remember? No, my schedule is already hard. So he's like, you want to switch into EA? Everyone's like into my office crying about it.
I don't understand why anyone would cry about it.
It's just
I'd be like, yo, oh, Miles.
I insult the people did not cry because I insult them. People cry because they're great.
Better idea.
Yeah.
I don't insult people unless I know you. Like I know Arthur, I insult him. But
He goes, "Arthur looks funny."
but Elizabeth, did I ever insult you?
no.
Yeah. See, I only
He even
insult the
told me
people.
everyone that she looks like.
I insult the people I actually like. No, I'm just kidding.
He literally like the second week of school.
No, I won't insult
He went,
somebody
"Oh,
like I'm gonna
no,
get myself in trouble. Like I'm gonna insult somebody who can take it. You know, I don't know you enough to like insult you. But if I know you, I will insult you. Trust me.
Oh yeah,
I don't like middle class.
Oh, yeah,
What?
I'm there until 8 every day.
Oh girl,
Yeah, that's true. You take it pretty well.
I trained her.
What?
I trained Elliot to take my insult, bro. Do you know how long it took? 8th grade, I insulted her like one time. 2 weeks later, I'd be like, "I'm sorry."
So it's like meaning
It's like, yeah, you damn right you are. Like it took so long for her to have like some tough skin.
I think it's really important to have tough skin.
Yes, tough skin gets you places.
That's true.
I'm gonna be scared to
I got this.
we just have to find out how. Okay? How we're gonna get there, I don't know. When we get there, I'll call you. Okay? I'll send you a $25 gift card. I'll have millions. And I'll send you like $25. Okay?
Sure. By then I'm probably homeless, taking
Whoa, what?
money on the street.
Problem.
I'll be like, Arthur, please,
Yes, stop you beg.
please.
No, really.
Remember you failed me last time?
Yes, you know. No way you go homeless. You're too annoying.
Yeah, Devin's gonna get rich. He's gonna pay for it.
I'm gonna get rich. I wish that happened because I don't want to pay anymore.
You don't want to work anymore?
Make him pay a retirement fund, and then you can just quit like next year.
Uh,
Get it all back fast.
yeah, that would be awesome.
Yeah.
Yeah, I was gonna say church.
The funny thing is, like, even I win the lottery, I still probably come to teach.
Like, you enjoy it. Something like,
I enjoy abusing kids.
you know, have like a thing where it's kind of weird. Well, that's what most teachers don't come here because of money. Can you imagine? I hear in China, like, isn't in China they make like, you know, I think.
In China, they don't pay much either. But in Finland,
Oh yeah.
Finland, in Europe, they pay a lot more. Or Saudi Arabia, they pay a lot. But they used to pay a lot not anymore. So people actually, American, will go teach in Saudi Arabia.
Like, there's no issue teaching because I don't know. If you teach here, it's because you like it. If you teach in Saudi Arabia, you want money. Like, that's ridiculous. You're not half bad.
Starting from the beginning, it's not gonna change my hair. I look bald. What I look like. You can see my scalp.
Dubai or minus.
What's your head shape? Is it like this?
Oh no, you're looking at my face right now.
No, the head shape would be really. Wait, do you have?
You guys finished clapping?
No, I've never seen it.
How many asymptote are they?
Don't get a buzz. Don't get a buzz.
Three. Where's the x-intercept?
I think people will.
1, good. Okay. Yeah, it's at 1. X-intercept's at 1. Because numerator equal to 0. Numerator equal to 0.
That was so corny.
Where's the y-intercept?
1/6.
1/6, good. All those points are valuable for you to graph.
Oh, Ellie Mae, look at it. There's a joke.
I'm just gonna write that down. So you remember.
You guys, why are you asking me? Should I do that?
Asymptote is at 9.
Yeah, but like in a really obvious way. After the denominator, she confirmed. Ella.
I wrote down from the notes. Denominator.
Should I be mad?
So there's the asymptote here.
So should I just say
And you study the end behavior. You should be able to graph it. I don't have time to graph it, but
you're right.
Come on, explain to me in fact.
oh, it's x minus 3. Sorry, you're right.
Yes,
You ready?
I corrected Mr. Yang.
What?
I just corrected Mr. Yang. The fact right here, he was actually getting.
You just felt
I was like, there's no actually. There's no. 1 minute ago.
Are you ready to go on a card?
I feel like it's something. I actually get
You finished? Kevin, try your best. I'll press it. Huh? Did you try? Or you just give up? There's a difference. Try or give up. Hi, Andy.
Hello, Mr. Gibbs.
You ready?
Yeah.
Oh, you can't just interpret this like. No. Okay, that's
Bro, next week.
Arthur? He's helping me.
That's you know we're
Why?
I did, bro. I was the one that was least rough.
Yeah, I'm one of them. No, today and yesterday. Because I was really. You know, like I was so tired that I was asleep at my desk.
Yeah.
Man, bro, every time I look at you, you think about the sense it freaks me out.
Yeah, you look pretty similar.
No, yeah. No, I look the same. I don't look the same, but I look the same. You know what I mean? But it's so freaky. Like, how does that happen? I know. Anyway, I just had to say that.
No,
I had to speak my mind. Yeah. Oh my gosh, that one day hurt so much. That like, yeah, that scared the shit. So stalker vibes. Like, can you see how that could be a little scary? Because you look so different.
Yeah. Did you see me when I cut off all my hair? Or did you just remember me talking?
There's a window right there.
Because I cut my hair in about 6th grade.
When did you move?
You moved during summer.
I moved at the end of sixth grade. I moved going into seventh grade. My first year here, we're going into seventh grade.
Can I move your backpack?
Yeah, go. Yeah, I don't know. Crazy how life works out.
Yeah.
I knew him in elementary school
No.
in Texas.
Yes.
I know, right? Yeah, I know.
Okay. Okay. Too late.
Like with your Roman Empire. that could be my Roman Empire.